Okay, I think that we can start. So, hello again. My name is Nadine from Kibo APC Secretariat, and I will be guiding this session about the 6th Kibo Robot Programming Challenge, known as Kibo RPC. So, thank you for attending these guidance sessions, and let's begin. So here is today's agenda. We will start with an overview of the Kibo RPC. We will also explain the preliminary round and the final round conducted on the International Space Station. And at the end of this guidance session, we'll have a Q&A session, and we may be able to answer to your question via the chat or the question Q&A capacity of the meeting. So even during the explanation, please feel free to use the chat and the Q&A ability of this meeting to ask your question. Okay. So first, we'll start with the KiboRPC overview. So the Kibo Robot Programming Challenge is a robot programming competition for students in which students can compete to complete a given mission using robots on the International Space Station. I will say ISS from now on, but it's International Space Station. So you can use the robot on the ISS with the action student have programmed on the robot. So this program is open to graduate students and undergraduate students from all around the world with a focus on the Asia-Pacific region. And all the details will be written in the guidebook, so please read the guidebook as well. And the KiboRPC aims to increase your skills, your expertise, and your aspiration in science, in technology, and in mathematics. Through this program, you will understand the differences among a simulator environment and the real environment of space. And you will also learn about the position and the attitude estimation of the space robot, as well as the error correction. Overall, we hope that this competition will be a great learning experience for you all. So, I would like to take a moment to explain what is the International Space Station, in which the final round will take place. So, the ISS is a huge facility where astronauts can implant experiments. The ISS is located at 400 kilometers above the ground in orbit, and the final round will be conducted in the Japanese experiments module Kibo that you can see on the screen here. You'll have also American, European, and Russian module on the International Space Station. But this time it will be in the Kibo module. So now the overview of the Kibo RPC. So the Kibo RPC is a robotics programming competition where participants can control a robot on the ISS using the programs that they have created, as explained before. So there is two types of free-flying robots on board the ISS that I would like to introduce to you. First, you have the INSPO, which is a JAXA robot, so Japanese robots, used by the crew for routine video footage of the ISS. And second, that you can see here on the screen, you have Astrobi, which is NASA robot that can help astronauts with a lot of daily tasks. So since last year, the two robots are used for the Kibo RPC. Before it was only the Astrobi, so the NASA robots. But this year you will have to program and operate Astrobi, while INSBO will be used as a camera to film Astrobi moving on in the ISS during your run. So basically the program is for Astrobi, but INSBO is there for the programming as well, for the competition as well. Okay. So every year, the Kibo RPC asks the student to create a program for Astrobi, but the mission of the robot is different each time. As you can see on the screen, you have the summary of the mission. And through this competition, participants can learn about, as I said, the scientific, technological, and mathematical skills and expertise, and the position and attitude estimation and correction for space robots. And it's the same for every year. And you can also see an overview of the number of the participation for previous year on the screen. And since 2020, the participation ratio has greatly increased. The number of teams and the participating countries has doubled since the first edition. And so it's a great increase as well. So as said, you have a focus on Asia Pacific countries, but I will explain a little bit later which country can participate to the Kibo RPC. So now we'll see the details of the 6th Kibo RPC, so this year's competition. So the game story of the 6th Kibo RPC. So this time the story follows a space pirate named Intbald I, or IB1, who over the course of its short life gathered cosmic treasures and hid them somewhere inside the Kibo module of the International Space Station. And astronauts hold clues about the real treasure hidden by IB1, but no one knows its exact location. So your mission is to work together with Astrobi to find the treasure hidden by the space pirate IB1 before any rival does. So of course, this story is purely fictional, but through this scenario, participants will develop an autonomous control program for the space robot Astrobi. So this robot developed by NASA is equipped by with various cameras, obstacle detection function, and signal lights, among other features available to participants. So you have the list here. And you will need to make a full use of this function to complete the mission. So cameras, laser, you have the arm, and the signal lights. And here you have all the specs of the Astra B. Okay, so now we'll explain the mission and the rules. So here you have an overview of the game and your mission. So first, when you move the Astro B, it means that the game is starting. Then your Astro B will patrol inside the Kibo module and accurately read the image on the item and at the designated areas. After the patrol, you go to the astronaut and report what you have read about the items. Then the astronaut will hold and show the target item. So this is the item that you have to search. You read the target item and match the item from images that what you have read during your patrol. Then you go to the area where you have found the target item and take a snapshot, a picture of the target with the camera of Astrobi. And then you light up Astrobi's signal lights to notify the astronauts about the location of the target. So here is some tips that the faster you finish your mission, the more you get bonus points. So you have to be quick to finish your mission. Also, when the Astrobi pass go through Oasis Zone or read image from the Oasis Zone, I will explain later what is Oasis Zone, you earn bonus points according to the time you spent and further the location from the item within the same Oasis Zone. So you have some areas on the Kibo module where you can gain some points if you pass through this zone. So I will explain quickly the glossary for the item. So you have 6 important terms. The first one is lost item. It is a general term including landmark item and treasure item that I will explain a little bit later. It's all the item in general. The second one is target item. So the target item is the item that the astronaut is looking for. It is printed with real treasure per. It's printed with real treasure plus a mixture of treasure item and landmark items. And the third one is landmark item. So it's a kind of lost item. You need to report this landmark item to the astronaut after patrolling each area. The fourth one is the treasure item. So it is also a kind of lost item that the astronaut is searching for, and your mission is to look for the real treasure and to take a picture of it. So the fifth term is R tag, RAR tag. So this R tag will allow Astrobee to recognize the location. It shows a lost item or a target item. And the sixth term is area. So you have 4 areas or location inside the Kibo, and the lost item will be displayed in this area. So as seen here, you have 1, 2, 3, and 4. And here are the items. So there is an information about the AirTag. So there is 2 kinds of AirTags. You have lost item and target item. The size of the displayed area and AirTag are the same. Here, you have all the specs. Okay. So now this is a list of lost items. As said, you have 2 kinds of lost items. You have treasure items and you have landmark items. So as you can see, there is 3 kinds of treasure items and 8 kinds of landmark items. The final target will be randomly selected from the treasure items here. And the level of the lost item placed will vary depending on the difficulty of the simulator, and the number, the type, and the size of the item will change according to the level as well. So on the same picture, you can have a treasure item and landmark item mixed on the same picture. But what you have to search is a treasure item, not the landmark item. Okay, so here is a list of the samples of the lost item using the landmark items only. As you can see in this chart, the number and size of the lost item placed in each area will vary depending on the difficulty of level. So the first report will be on this landmark item only. So here you have the 4 level, and you can see that the size and the position is different, and the number of item as well. Okay, so here is the sample of lost item with a mixture of landmark items and treasure items. When you patrol, you will read lost item with only landmark item or a mixture of landmark item and treasure item. So you have 2 patterns. You can have either this kind of picture, either this kind of picture. Yet you have to report to the astronauts landmark item only first, but keep memorizing the mixture item for later use. So first, when you do your patrol, you report on the landmark item, and then you will have to look for the treasure item that can be on mixture picture, like here. Okay. So now you have on the screen a sample of target item. So that's the kind of picture that can show you the astronaut. It's consisting of a mixture of landmark items and a treasure item. And the size and number of items vary depending on the difficulty. So the astronaut will show the real treasure called the target item. So you need to match and to look for the treasure item. So for example, here it's a kind of, I don't know, emerald or diamond, emerald, I think. So here the AirTag, you have 2 landmark item and the treasure item, and this is the image that you have to look for. Okay, so now you have to find the treasure item indicated by the astronaut among the lost item placed in each area. In this case, the treasure item is an emerald, as said before, and in the area 1, there is an emerald in the lost item. So you move the Astrobee to the area 1 and take a snapshot of the target item. Here. Okay. Sorry. Yes. So the real treasure here is the emerald, and you can use the landmark to target the real treasure as well. So I will skip this. You have few fake treasure. For example, here you have the diamond, but the real treasure is the emerald, and you have other target. You have other landmark item as well, marked in blue, that you have to report on the first round, first patrol. Okay, and this is the real treasure. Okay, so now I will explain what will your mission be concretely. So first, the game begins as Astrobi undock from the docking station here. Then Astrobi begin its patrol to identify where the treasure are hidden in the different location. So you go to the area 1, 2, 3, and 4 and note all the landmarks. As Astrobi patrol the area, there is designated oasis zone. So this is the blue zone that you can see on the screen. And it's all within the station. And participants are free to decide whether they want to pass through this zone or not. So it's your decision. However, while Astrobi is inside the oasis zone, point will be awarded based on the duration of the stay. So the more you stay in the oasis zone, the more the point will increase. So you have to be really strategic and strategically plan your route, considering whether to navigate through oasis zone or take an alternative path. And for more detailed information about oasis zone, please refer to the rule book. Okay. So after completing the entire patrol, participants will report to the astronauts on what landmarks they were found and where they were found. Just 1 second. Okay. So by analyzing target items, image provided by the astronaut, participants will identify the real treasure using the image of the target item, aka the real treasure obtained earlier. And Astrobi will navigate close to the treasure location and capture a snapshot of the treasure. And you have to be careful about the fake treasure, of course. So this is the real treasure. Okay. So after shooting a snapshot, Astrobi will activate its signal lights to indicate the treasure location to the astronaut, marking the end of the mission. And the total time limit from the start of the game to the final mission report is 5 minutes. So you have to do it all within 5 minutes. And you have to develop your program that completes the mission within this time constraint. If not, the game is over. So it's a game over. Okay. So, okay, now I will explain to the scoring factors. So you have 5 factors that you need to be aware of. The first factor is whether whether it's matching the area and the item. So in each area, there are lots of items that are randomly placed, and you earn points when you accurately process the image and recognize the kind and number of landmark items among the lost item randomly placed in each area. So the higher the level, the higher the score. So it's a difficult image, more points, basically. And please note that the treasure items may be displayed together with landmark items, but unfortunately, They will not be counted even if you link a treasure item to an area at the first report. The first report is really focused on landmark items. Okay. So the second one, the second factor is coordinate the position of the astrobee when the astrobee report to patrol completion to the astronaut. So please be aware that if the astrobee is within the 0.3 meter from the astronaut, your team will earn additional points. And if the astrobee position is more than 0.3 meter from the astronaut, there will be no points. So the closer you are, the more the points you earn. Okay, so the third point is that you can earn point only when both the camera angle and position at the same time of capturing the target items meet the scoring criteria. So for the camera angle, it is evaluated based on the position and the orientation of the nav cam and the target item at this time the target item is reported as found. So if the item falls within a 30-degree field of view, the requirement is considered met. So it's okay. And for the position, the requirement is considered met if the navcam captured the image within a distance of 0.9 meters from the surface of the designated area. If either the angle or the position does not meet the criteria, the attempts will not be counted. So points are only awarded when both conditions are satisfied. So please make sure to keep that in mind. You have to have the degrees and meter of the navcam into account. Okay, so the first one, the first factor, is when you find and report the target item, you will receive additional points according to the time remaining within the time limit. So the faster you report, the more additional points you will receive. So if you do it in 5 minutes, you will have no additional points. If you do it in, I don't know, 4 minutes and 30 seconds, you will have additional points, for example. Okay, so the fifth factor is routing. So the flight paths are the waypoints, to be more clear. The oasis zone is one of your consideration whether you take it in your waypoint or not. So your team will get extra points on how long astrobee stays in an oasis zone. However, if it is in the same oasis zone, the closer it is to the last item, the fewer points it gets. And the more far it is, the more points you will get. So if you want to have a lot of points, you have to target oasis zone that are a little bit far from the target item. So you have to decide if you the pro and cons of your waypoints and times, if you want to pass through oasis zone or not. It's your strategy and it's you to have to think about that. Okay. So now I will give you a few tips which are really important to succeed the mission and to have a higher score. So first, you have to be sure to scan correctly the image of astrobee, so it can recognize them. And this year, it may have several images on the same location. So you have to focus on the accuracy of the image detection in your program. So it's really important to identify the image because it will have a huge impact on whether you will succeed the mission or not. So really, image recognition first. Second one is you have to think about the optimal route to move toward objects efficiently while passing through the oasis zone. So an optimal route may lead to a higher score. Oasis zone give points And the longer you stay, it gives points. But at the same time, if you finish your mission quickly, you will have point as well. So you have to try different combination of program and to see what is the more strategically efficient for you. Okay, and third, you have to anticipate problem that your robot or your program may face. For example, your program could be stuck in a loop, or image could not load, or the mapping of your program could be weak. So you really have to train your program and to see all the flaws of your program to have a better score. And the fourth tips is the more you train and correct your program, of course, the stronger your program is going to be on the real run. So we encourage you to use the simulator and train as much as you need your program because it's a tough competition. Okay, so now I will explain quickly the main milestone and the main schedule for you. So here you have the different kind of milestone, and on here you have what you have to do. So for you, it's sending application, write the code, participate in the preliminary rounds, and if you pass by you succeed the preliminary rounds, you have to modify your APK, so your program, and you have the on-orbit operation, and then the final event to be quick. So now I will be explaining point by point what you have to do with the date and all. So first, how to participate. You can access to the competition website and to read the participation guideline and register your participant information via the registration URL. So the registration deadline is May 12 at 11:59 Japanese time. So be careful of the time because it's Japanese time, it's not your local time. So you have really to send your application before May 12. Within a few days, you will receive a confirmation email and login information for the simulator page. You can use then the simulator which is available on the website to develop your program. So to train and to develop your program. Now, about the preliminary round. So the preliminary rounds will take place in your country or in the country you applied for participating in. So you have to submit your preliminary rounds program via the simulator by mid-June. It's June 19. And again, it's the same times. It's Japanese time, 11:59. So be careful as well, because it's too bad if you miss the deadline. Okay. Then, of course, you have the simulator open. It's open now, and you can start to develop and train your program as soon as you're registered. And also the preliminary round will take place sometimes between June and early July, which each participating countries and region holding their own preliminary rounds during this period. So for this, you have to reach out your country responsible person, the person in charge in your country. And for the final rounds, it will be international. So it's the best team of each participating countries, and it will take place in the ISS. And for the event, it will be in Japan. So the team that qualify for the final rounds can refine their program before the final competition. That's where you see this period here. And also, I have to say that due to ISS limitation, if the number of finalist teams needs to be reduced, a selection will be based on your preliminary round scores. But it should be okay, I think. And the deadline will be by the end of August to finalize your APK. Okay. And for the final round schedule, you have 2 steps. So you have your EPK, so your program final round, which will be, I think, in September. And the finalist team program will be executed on board the ISS using Astra B. So at this point, result will not be announced. And then you will have in November the final round event. And the astronauts will present explanation and results of the final run held in September. So this event will take place on Earth and serve as the official result announcement. And it will be both online and in Japan in the Tsukuba Space Center of JAXA. So if you can participate, it will be really great, I think. Okay. We'll give you, of course, further details about the final round after the preliminary round. Okay, now how to participate. So the first step is to fill your registration on the KiboRPC website. And to participate, you have to be a student. You have to be a team between 3 and 8 person. And you have to have a team leader. So this is the 3 big condition for registering to KiboRPC. And then after registering, you will have a completion notice by email with the login ID for the JAXA simulation environment. So please don't forget the deadline application in May 12. If you need to update the information of your team, for example, the members or something like that, you can let us know by email and indicate your name, the name of the team, and you can do modification to your team information even after the application deadline has passed. So first you register on May 12, but even if your team change or anything, you can have some modification if you contact us by email. Okay. So now, depending on the criteria you meet, you have different way of participating. So for example, even if you're not from a country that is, even if you are from a country that is not a Kibo RPC participating country, you have the possibility to participate through UNOOSA, so UNOSA, international slots. So you have few conditions. If your nationality or the location of your school is in one of the Kibo RPC countries, you can apply in this country. And if not, you have the UN slot. If you need some information, you can look Kibo RPC UNOOSA on Google, and you will have all the information. Okay. So next, I will explain the process after the registration. So from the time of the application until the simulator, for the, so for the time of the application, you have a self-study period that you can do from now on because you have to learn a little bit. And during this time, you can learn about astrobic programming through NASA publicly available GitHub resource. So this information is also included in the guidebook, so please refer at it as needed. And the programming language used in this competition is Java. So learning Java in advance is really helpful. Now we are on April, end of April, so you have to learn really quick, I think. So yeah, you have really to learn Java to develop your program for the preliminary round. And additionally, it may be beneficial to research AI-based image recognition technique used in this game rules, such as object detection and pattern matching, especially. And also for beginner, we have a tutorial video, so you can check them out on the Kibo RPC website as well. So the simulator is now open, so you can also train with the simulator directly, but if needed, you have all this study period if needed. Okay. So now I will do some explanation. All the information that we'll be giving are also included in the programming manual. So please consider this as a reference, but you can read the programming manual for more detailed information. So first, to set up your computer, you have to check your PC specification. So a typical PC specification should be good enough for your simulation in the web environment. And once you have confirmed the specification, you have to install Android Studio. Next, you have to download the additional components of the template APK, which can be found in the download tab on the website. The template APK is a program area of Astrobi that cannot be created by the participant and has been prepared in advance by JAXA. So you develop only a part of the Astrobi program, of course. So participants are asked to write their own program using the template. And as said, the language is Java. So when all the downloads will be completed, you can start to develop your program and try to improve it. While program can typically be executed in a web-based environment, it's also possible to set up a local simulator if needed. And for details on how to set up a local environment, please refer to the programming manual. Okay. So I will quickly explain how to create your program. So the process of creating the program is also explained in one of the development tutorial video. So you can take a look of the video for more information. So first, you have to build a program using the Android Studio on the PC that you have set up. So when you open the download template APK with Android Studio, you will find a file called Your Service in the lower layer of the app folder. When you open this file, you will see codes on the right. So you have this on the screen, Your Service. And in the area indicated by the red square here, there is a line that says, write here your plan. So this is where you will write your program. And the program codes available in writing methods are described in the programming manual. So you can take a look to that. And if you want to add a function that is not in the command list in the programming manual, please add yours by yourself or import the library. So next, upload the APK you created using your account. You log into JAXA simulation server using the ID you received after registration. And when you log in, you will see a screen like this. When you click on the simulation tab, you will see a screen like this one. And you can upload your APK or drag and drop it in the specific area here. After uploading the APK, you start the simulation and let your program run. So once you uploaded the APK on the simulation tab, the start button will become active. So please click on it to run the simulation. And also you may set the difficulty level from this drop-down box on the simulator level. So you have all the simulation level here and the start simulation here. Okay, then you will get your results. So when you click on result, you have the result button here. You will see a screen like this one, and you can see a list of the results that you have done. When you conduct more than 20 simulations, you will need to delete previous simulation results. So it's the capacity you have. You can only have 20 simulation at the same time. So you need to move some space if it's more than 20. Okay, so if you click on the view button on the right side of the simulation results to see the details, so you can save and view your data up to 20 simulation results, so you can view 20 simulation results details. Okay, And this is an example of detailed results. You can see the game time and score, and you can also use the button at the bottom of the screen to view the simulation results movie and download the simulation log file. So, where are the button? I don't remember. Ah, yeah, you have download APK here, for example. Okay. Ah, yeah, it's here, sorry. Download the log file and you can see the simulation as well. Okay. And you have the pattern, the list of the last item and the results of the image recognition. Okay. So now you have to analyze the result and give a feedback to the program that you have created to improve it. And you have to repeat this process to create a program for the preliminary round. And for more detailed procedure and example of the program creation, please refer at the tutorial video on the KiboRPC website. And if you have additional question about program creation or anything, you can feel free to contact us by email anytime. But you have to note that depending on the issue that you have, we may be not able to answer to the question for the sake of the fairness of the events, to not be unfair to other teams or participants. Okay. Now about the preliminary rounds, I will do some explanation. So in the preliminary round, each country space agencies will run APK submitted by the deadline using the simulator, and the teams with the highest average score will access to the final round. So it's each country. You have one team in each country that will win the competition. We explained the mission details earlier, but if you need more specific information, you can refer to the rule book. Okay, so you have to submit the application form before the deadline, as said, and during the APK submission period, a submission feature for the preliminary round program will be added to the simulation platform. So please submit your program for the preliminary round through this feature. And the APK submission period will be late May to mid-June. I think it will be around that. And please note that the submission after the deadline may result in disqualification for the preliminary round. So really be careful of the date for the submission of the APK. So additionally, the preliminary round in each participating country will take place one day between late June and early July. So even though you can create up to 20 data of your APK, you can only submit one APK for the preliminary round. So each team will have 10 runs for their APK, and the random factors are the same for all the team, and the score is calculated on the average of the 10 runs. So one APK and 10 runs by each APK. For the preliminary round, it's organized in each country or region, so the organization can be different regarding where you are from. So, for example, in Japan, we will hold an event for the preliminary round, and the event will be broadcast on YouTube. And you can see also the last year competition on YouTube. I have the link here that we will send you later. Okay, so now about the final round. So the final round is conducted by installing the program to Astro B in orbit on the ISS, so on the real Astro B. So the details and the program submission date will be announced a little bit later to finalists, but the program has to be submitted in advance. For now, we are expecting late July to late August for the final round program submission. And of course, the difficulty of level and all are random as well. So there is one thing that you have to know about the final round that is really, really important. we have one really significant difference between the simulation environment and the real environment. And this difference is the accuracy of the self-localization. So Astrobi determines its current position and orientation using a method called sparse mapping. And it works as follows. So 1, you have pre-flight preparation. You have initial image of the Kibo module that are collected in advance to create a map that is stored inside Astrobi, in the memory of Astrobi. 2, you have in-flight localization. So while flying, Astrobi captures image with its camera and matches them with the pre-created map feature points to estimate its position and orientation. So one map already in the memory of Astrobi and one on real time. However, in areas with few distinguishable features, Astrobi may experience self-localization loss, leading to loss of flight control. And it's really important to have that in mind because it has a real impact on your run. So in contrast, the simulation environment does not replicate this self-localization method. As a result, you can have issues such as decreased accuracy or self-localization loss, which may occur in the actual ISS during the final round and not happen in the simulator. So you have to be careful and have in mind that when you prepare as well your program on for the final round, because it will be more difficult on the final rounds with the real environment. Okay. So the final rounds will be consisting on 2 events. So you have first the APK final run, which is scheduled to take place in late September. And at this time, the finalist APK will be run on Astrobi on the ISS. And the finalists can watch the video of their run, but the results will be not announced on that day. So you cannot see the run of the other teams, just your run. And the second event is a final round event, which is an event where the results of the completion of the APK final run are watched with astronauts, and the results are announced as well to all the teams. And the format of the event is most likely to be on a hybrid format, as said, and we will inform you about that. But it will be online and on site in Tsukuba in Japan. Also, the final rounds event will be uploaded on YouTube at a later date. Even those teams who cannot access to the final round can watch the events as well. So it's nice. Okay, that's all from me. So that concludes my explanation. And thank you for your attention. And we look forward to your participation as well.